Hello children, Bindu is back. Previously, gravity, gravitation, gravitational force and gravitational constant are discussed. Now, without getting late, let us gather more information on acceleration due to gravity and free fall. Before that, let us focus on the learning objectives. Learning outcomes. After studying this topic, you will be able to know acceleration due to gravity, free fall, mass, weight. Keywords: acceleration due to gravity, free fall, mass, weight, gravitational force, gravity. When an object is dropped from some height, its velocity changes continuously. So, when an object is dropped from some height, a uniform acceleration is produced in it. This acceleration happens by the gravitational force of the earth. The uniform acceleration produced when a body is dropped from certain height due to the gravitational force of the earth is known as acceleration due to gravity. It is known by the letter g. The value of g does not depend on the mass of the body. The value of g changes slightly from place to places, but almost everywhere it is taken as 9.8 meters per second square. When an object falls to the ground under the action of Earth's gravity, its velocity increases at the constant rate of 9.8 meters per second. When a body is dropped freely, it falls with a positive acceleration of 9.8 meters per second square. And when a body is thrown vertically upwards, it undergoes a negative acceleration of 9.8 meters per second square. The velocity of a body thrown vertically upwards will decreases until it reaches zero. The body, when falls back to the earth like any other body, dropped from that height. If we drop a body of mass m from a distance r, where r is the radius of the earth, and the mass of the earth is m, then the gravitational force exerted by the earth on the body is given by the universal law of gravitation. This force is exerted by the earth, which produces acceleration in the body, due to which the body moves downwards. Now, let's recall Newton's second law of motion. Newton's second law of motion gives us a relationship between force and acceleration. Newton's second law says that force applied on a body is mass of the body multiplied with acceleration of the body. F is equal to m into A. M is the mass of a body and A is the acceleration of the body. So, acceleration of the body is given by A is equal to F by m. If this A is the acceleration of the body which is dropped and F is the gravitational force by the earth that acts on the body which pulls it towards itself. Then the gravitational force formula for F, which is F is equal to G into capital M into small m by r square, can be used in a is equal to F by m. The acceleration produced by the earth is known as acceleration due to gravity. And represented by the symbol G. So, by writing G in the place of A in the above equation, the equation can also be written as the value of G can be calculated by using the values of G, which is the universal gravitational constant, m, which is mass of the earth, and r is the radius of the earth. The value of G is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. The value of mass of earth is 6 into 10 to the power of 24 kg. The value of radius of earth is 6.4 into 10 to the power of 6 meters. Using the values in acceleration due to gravity equation, value of G will be 9.8 meters per second square. The acceleration due to gravity is given by the formula does not have the mass of the body on which the force of gravity by earth acts. The acceleration due to gravity does not depend on the mass of the body. All the bodies, whether heavy or light, fall with the same acceleration towards the surface of the earth. What happens when we drop an object from a height above the ground? The body falls down, but the velocity of the body changes with time. The body, while falling down, accelerates. The falling of a body or object from a height towards the earth under the gravitational force of earth with no other forces acting on it is called free fall. A body is called freely falling body or freely falling object when it falls freely because of gravitational force of earth. The mass of a body is the amount of matter or material in it. The mass of a body or object is commonly measured by a weighing machine. Mass is measured in kilograms in SI units. The mass of a body or object does not change from place to place. Mass of a body is usually denoted by the small m. The mass of a body cannot be zero. The earth attracts every object towards its center with gravitational force. The weight of a body is this gravitational force with which it is attracted towards the center of the earth. That gravitational force will be the product of mass of the body and the acceleration of the body when it falls freely because of gravitational force by earth. This force is given by F is equal to m into g. This force is the weight of the body. So the formula can be written as W is equal to m into g. W is the weight of the body. The weight of a body changes from place to place. In space, where g is equal to 0, the weight of a body becomes 0 and we feel true weightlessness. Thus, the weight of a body can be 0. Astronauts float in space because weight of a body is 0 in space. As weight is a force, it is measured in newtons. N. Points to remember. The uniform acceleration produced when a body is dropped from a certain height due to the gravitational force of the earth is known as acceleration due to gravity. The value of g changes slightly from place to places, but almost everywhere it is taken as 9.8 meters per second square. When a body is dropped freely, it falls with a positive acceleration of 9.8 meters per second square. And when a body is thrown vertically upwards, It undergoes a negative acceleration of 9.8 meters per second square. The acceleration due to gravity is given by small g is equal to capital G into m by r square. The acceleration due to gravity does not depend on the mass of the body. The falling of a body or object from a height towards the earth under the gravitational force of earth with no other forces acting on it is called free fall.